Okay, so now I'm going to present my project proposal. My project is about pose and sign estimation with RGBD image, a method based on normalized object coordinate space, and my project is mostly based on CVPR papers, and as shown in this slide. So starting from motivation. So in robotics manipulation, so given a manipulator in the workspace like this, and given a target object that we want to manipulate in the workspace like this, so to make the robot can approach to the object and grab it or pick it, so we have to know the relative position and relative pose of the object with respect to the world coordinate frame. So how we can estimate the 6 degrees of freedom parameters, including 3 DOF for the rotation or orientation and 3 DOF for the position of the object. So in this case, we can use an RGBD camera. So the camera will capture the image of the object, and then we can proceed the image to estimate the transformation matrix of the object with respect to the world coordinate or the robot coordinate here. And based on this transformation, then a planning controller can plan a joint reference trajectory for the robot to manipulate the object as we want. So what is the method we are going to use here? So in the paper, they introduced this kind of framework. So there is an RGB image we capture from the camera, and this RGB image will be fit to a convolution neural network. And actually, there are two CNN in this framework. One will be used to predict the class label or the category of the object. That means the capture object, it is a laptop, it is a cup, or something else. And another CNN, it will estimate the normalized object coordinate space map. Now, this map actually also an estimation, a 3D estimation of the object, and the camera also provides a depth information of the object. So by using the depth information and the normalized object coordinate space map, so we fit those two information into an algorithm to estimate the pose of the object. And the algorithm to estimate here is it uses the least square optimization. So in the fact I intend to contribute on on this component, on this part, that is, I see that in the paper the input image is mostly the objects are mostly separated. So what if the objects are overlapped? So we can consider to evaluate the framework in this case, or we can consider to improve the pose estimation algorithm in here. In the paper, they used a least square optimization algorithm to estimate the pose of the object by with the depth and the NOCS map information. So I'm still considering we can consider to test with the different training data set where the objects are overlapped, or we can improve the pose estimation algorithm in here. And regarding the experiment, because I don't have a real RGBD camera, so I will implement the algorithm in a simulator that is a Gazebo combined with a ROS2 environment to to validate the effectiveness algorithm of the framework. So that is my presentation.